Hello everyone. So this is the recording for today's exam one SI review. I forgot to hit the record button when I started the session, but a good thing is the session went for full 2 hours, but this solution parts would not go for full 2 hours, I believe. So this is the real quick run through all the questions. I highly recommend that after every question you pause the video, try solving it on your own, and then play to see how I solved it. This will help you to remember things better and recall it during the exam. And so every time I say pause the video, actually pause it, solve the question, think over it, and then come back to the video. Okay. Okay. So I'm going to start with the session. Hope you guys can see my screen. First question. So the exam covers module 1 through 3, and I'm not going over module 1 because it's very like general information, and I believe you can like cover it on your own. Module 2 and 3 is what I'll cover in the review because they're going to lot of like information which you need to learn and practice. So that was on the that was on the exam review. Start with module 2. The first part is about accuracy and precision. And so my question to you guys is, can you, in your own words, describe accuracy and precision for me? So go ahead and pause the video, think over it, write it down, and come back to the video. Okay. I'm gonna go ahead and write the thing. So in the session, people said that they remember accuracy as something which is closest to the answer. So if you get a measurement or your answer and that answer is very close to the actual answer, that means your answer is very accurate. So being close to the answer means accuracy. On the other hand, precision, people said that precision is something like the measurements are close to each other, but not necessarily uh, correct answer. Not necessarily the correct answer. So you can take 10 measurements and they can all be really far from the answer, but all of them I clumped up together near the same number. So that means your answer is precise, but not accurate. And someone also said that something can be accurate and precise at the same time. So you can take multiple measurements which are very close to each other and around the right answer at the same time, making it accurate and precise. Also, something can also be accurate, but oops, but not precise, or vice versa. So you have measurements which are accurate. The average comes down to the same like right answer, but they're so far apart they're not very precise. However, you can also have measurements which are very precise, but the average does not come near the right answers. They're not accurate. So both cases are possible. One more note someone made was that accuracy requires just one measurement. You can take one measurement and be the right answer, but precision needs multiple measurements. You can't say like, oh, I took one reading and this is very precise. The whole point of precision is that multiple readings are very similar. So you can't have precision with just one reading. You did multiple readings or multiple measurements. Okay, I'm gonna highlight this so you know that this is what I wrote. Cool. Okay, moving on to the next question. An example of this, if the slide is a very good visual example where there's a dartboard and multiple darts shot at it, and there are 4 cases where all the darts you shoot are close to the answer, far from the answer, very spread out. And so if you visit that question or that example, it's a great way of visualizing accuracy or precision. But there's a numerical question in the slide as well. I've changed the numbers up a bit, but the question remains the same, that Mike and I tried measuring number of grains in a rice bowl and they had 4 measurements. These are the numbers given to you. The correct answer, the correct measurement is 265. The question is whose measurements were accurate slash precise or both or whatever. So go ahead and pause the video, find a way to compare accuracy and precision for both answers, and then come back to the video and we solve it. Okay, I'm going to move on and find the answer. Best way to find the answer is actually average both the numbers. So I'm going to take my calculator and really quickly average the numbers in front of you. For Mike's calculations, the average comes out to be 68 plus 268 plus 271. So Ike's average is 269.25. So that's we can say 270, but for the sake of it, let's keep it like that. And Ike's average, let's calculate that one. 255 plus 247 plus 275 plus 283 divided by 4. His average came out to be exactly 265. So from this you can see that I'm going to start drawing on this. You can see that Ike's number was exactly the right answer. Okay, so I'm going to say that Ike is accurate because his number was exactly the right number. On the other hand, Mike's average was not the right number, it's off by a bit. But if you see that all his measurements are very equally spaced out from his average. So 270, it's almost the same number as this one. 268 is one off from his average, not the right answer, from his own average. 268 again is one off. 271 is one greater than his average. So his numbers were very close to his average. So his answers are very clumped up. So I'm going to say that Mike, on the other hand, even though he was not accurate, he was precise. Okay, so that could be a good question on the exam where Dr. Peters gives you a bunch of numbers and finds which is accurate, which is precise. Perfect. Okay. Moving on to significant numbers. In significant figures, this diagram, which I took out from the lecture slide, is a good way of learning it. A good way of remembering what I mentioned in the session was if you have a bunch of non-zero digits, they're always counted for significant figures. The problem comes when there are zeros. So if there are zeros in between non-zero numbers, those zeros always contribute significant figures. So in this case, I have 1, 2, 3, 4, and 5 digits. So there are 5 sig figs. That's perfectly right. As you count here, oh, in this case too, I have 5 digits in this case, but this 0 is behind, like on the right side of the decimal point, and it's mentioned. So in this case, it's counted for sig figs. However, if it was over here, this 0 would not count for sig figs. Okay. In this case as well, these zeros are between two non-digit zeros, so they're counted for sig figs. In this case, this 0 is mentioned after the decimal place, and because it's mentioned, it's going to be counted for sig figs. So there are 3 significant figures here. In this case, decimal point is after the 0. So everything on the left of decimal place is counted for significant figures. So there are also 3 digits. But if I write just 20 or just 120, that 0 is not counted for significant figures because there's no point over here. So I would only say there's one significant figure in this case. Okay. I'm going to give an example of PEMDAS is how to solve multiple numbers question. And so let's write this out in a mathematical form. Then typing out 6.0 plus 1.03 times 10 to the power 3 and the whole divided by 1.9800. So PEMDAS says follow the parentheses first. I'm going to solve everything inside the parentheses at first. Even then, oh, this rule is also like iterative. So once you solve it, you can go back to like the P and then go like solve everything in the way. So if you say PEMDAS, I'm going to do parentheses first. And inside the parentheses, I have a bunch of operations. So I'm going to go back to PEMDAS and say parentheses, nothing inside the parentheses, exponents. So I have an exponent over here. I'm going to open up the exponents real quick. So it's going to be 6.0 plus 1030 point, because the exponent, and then what my denominator was as it is. So now this still remains in the parentheses. So I'm going to reapply PEMDAS. No parentheses in this, no exponents in this, nothing to multiply or divide, but something to add. So I'm going to go ahead and add these numbers together. So I get 1036.0. And now remember that when you try to round up things, do not round up just yet, because there might be a rounding error. Round in the very end, and then in the end I get 1. 9800. And so this division comes out to 523.2323, and it keeps going. And so for significant figures, I'm going to round this up like this. This one contains 1, 2, 3, 4, 5, 6 figs, while this one contains 1, 2, 3, 4, 5, 6 figs as well. So I'm going to round this number up to 5, 6 figs. If any of these numbers had less number of significant figures, I would round it up to the least number of significant figures. Okay, so go ahead and read these rules on how to round significant figures, and that'll help you a lot. Okay, I'm going to move on to the next part. Unit conversions. So to convert units, I have given a few notation, like a few notes. So go ahead and read these notes and follow them. But I'm going to start with the first question, which is convert 400 nanometers to meters. And so if you don't know, the conversion factor for meters to nanometers is 1 meter equates to 10 to the power 9 nanometers. I think this will be given to you in the exam, so do not worry about it. So if I want to convert 400 nanometers, how would I do that? So go ahead and pause the video at this point, try solving it on your own, write it down, solve it, and then come back to the video. Okay, I'm going to go ahead and solve this problem. To convert 400 nanometers to meters, I'm going to multiply it like this. I do not want nanometers, and because that's in the numerator, I'm going to put it in the denominator, so they cancel off. But I can't multiply anything just by itself. That would like change the numbers completely. I'm going to do something to cancel, like to nullify it. So I'm going to put meters on top because I want meters as well. And to nullify it, I'm going to use the conversion factor. I said 1 meter equates to 10 to the power 9 nanometers. So this thing by itself means 1. So I'm multiplying this by 1. But the units are changing. So nanometers cancel off. What I'm left with is meters. And because this is in the bottom, what I end up getting is 400 10 to the power. Anything in the bottom of the exponent, when it comes to numerator, you change the sign. So it's plus 9 becomes negative 9. If this was negative 9, it would be plus 9. And the units left over are no nanometers, so what's left is meters. And that's my answer. Okay. I'm gonna, for one more question. The question here is, can you convert 1 over 500 nanometers? So this nanometer is in the denominator now, not in the numerator. Can you convert this to meters? So go ahead and pause the video at this point and come back to it when you're done solving. Okay, I'm gonna go ahead and solve this now. To convert this, what I'm gonna again multiply by something. In this case, I don't want nanometers, but now it's in the bottom, so I'm gonna put it on the top. So they cancel off, and then I want meters in the bottom, so I'm keep meters here. To make this ratio 1, I'm gonna use the same conversion factor. 1 meter equates to 10 to the power 9 nanometers, and then oops, my bad. My nanometers cancel off, and so what I'm left with is 1 over 500 to the power 10 to the power 9 meters. And so if you want, you can convert the 1 over 500 to a decimal and a fraction, but I don't care about that. I wanted to show you how to convert these meters, these units to a unit you want. Okay, so that's how you do it. If you have any questions about anything, feel free to email me and I can help you out through email. But I'm going to move on to the next part, is equation manipulation. And this is something you would actually probably use in chemistry for this course, because equations given to you in one form, and maybe you want to find something else instead of the thing the equation gives you. So you can always like rearrange the equation to make it in the form you want it to be. Okay, so first question is, can you manipulate m equals mdv to make an equation which gives in the form of which gives in the form v equals something? So instead of m equals something, you want v equals something. So go ahead and pause the video and try it on your own, and then come back to it when you're done. I'm going to go ahead and solve it. Since I have m equals dv, and I don't want the d on the left side, on the right side, I'm going to divide both sides by d. And so this cancels off, and what I'm left with is v equals m over d. Okay, that's how you do that one. For the next one, we have the equation formula for waves. Energy equals hc over lambda. I'm going to rewrite this for you so it's easy to understand. Hc over lambda. And my question is, find the equation which gives you lambda equals something. So you can go ahead and pause the video and then come back to it when you're done. Okay, I'm gonna resolve this question. I'm gonna solve this question now. Since I'm gonna change the color real quick. I had E equals HC over lambda. I want lambda to be the numerator. So I'm gonna multiply both sides by lambda. Okay, and then I do not want this E in this case, because then if I remove the E, what I'm left with is lambda, so that's what I want, right? So I'm gonna divide both sides by E. Okay, and by doing this, I cancel out the E from here and the lambda from here, and what I'm left with is lambda equals HC over E. So my answer would be HC over E. Okay, I hope that makes sense to you guys. That's how you manipulate equations. One more question here is, how do you go from Celsius to Fahrenheit? And the equation here is kind of complicated because it contains addition too. You find Fahrenheit equals 32 plus 9 over 5, and the whole 9 over 5 ratio is multiplied by Celsius. So you put the number in Celsius over here, like 32 Celsius, for example. You do all the operations, and then the answer you get is a number which is in Fahrenheit. So the question is, how do you convert this to give an equation in the form of Celsius equals something? Go ahead and pause the video. Try it on your own. This is a bit tricky, and people found it hard to do this one in the review. But after you're done, come back to the question and we'll do it together. Okay, I'm gonna go ahead and solve this question. To solve this one, first thing I see is I have two terms. I have 32 and I have 9 over 5c. I'm gonna keep the c in the way it is. I'm gonna move this 32 to the other side. So I'm gonna subtract 32 from both sides. So I will get f minus 32 equals 9 over 5 c, and then 32 from here got cancelled off, 32 subtracted. Okay, and then this is one term now. If I multiply both sides by 5 and divide by 9, I'll end up cancelling those things from here, but now those things are on this side. So my answer becomes c equals 5 over 9 times f minus 32. Okay, and that's what the final answer is. Okay, hope you guys understand that one. I'm going to move on to the next question. This is about calorimetry. So the first question is, what's the difference between small c cal and a big c cal? And small c cal equates to 4.184 joules. And so can you guys figure out what the big c cal equals to? Big c cal equals to still 4.184 joules or kilojoules. In this case, it is kilojoules. So big C cal is 1,000 times bigger than small c cal. That's the only difference. If I ask you to convert this kilojoules to joules, to do that, it's pretty simple. Okay, you know what? You try it on your own first, and then come back to the video once you try it on your own. But I'm going to try solve it over here right now. I want to convert 4.184 from kilojoules to joules, and the ratio is 1 kilo of anything is always equal to 1,000, or I should say 10 to the power 3. That's easy to like manipulate, joules or whatever it is. And so to convert that, I would divide it by kilojoules and have joules on top. 1 kilojoule is 10 to the power 3 joules. And so my answer becomes, this is the same as 4184 joules. So 10,000 times bigger. I'm sorry, 1,000 times bigger. Awesome. Okay, next question is, this involves using the formula for heat transfer. And so do you guys know what the formula for heat transfer is? The formula for heat transfer is Q equals mCs delta T. You know what, pause the video at this point, try naming what each variable means, like what does Q mean, what does M mean, what does CS mean, and then come back to the video once you identify what each variable means. I'm going to go ahead and write them down right now. Q means the heat transfer which took place, how much heat was transferred. M stands for mass. CS stands for specific heat. Oops, it's hard to write with the mouse on a Word doc. Specific heat, and delta T is the change in temperature that occurred. And so my question to you guys now is, how do you find the change in temperature? So you will be given two temperatures, an initial one and a final one. And to find delta T, you always do temperature of final minus temperature of initial, no matter what. Even if it's a question about heating or cooling, you always do final minus initial to get delta T. And that's one term. And so in this question, you have 100 grams of water going from this temperature to this temperature. And the question asked is, how much heat did I provide to the water in joules? And so go ahead and pause this video. Use this equation I just gave you to find how much heat was given to the water to heat up from 25 to 27 Celsius, and then come back to see what the right answer is. I'm going to go ahead and solve it. Q is MCS delta T. In this case, M here is 100 grams. CS is given to you 4.184 joules per gram Celsius, and delta T would be final 27 minus 25, which would be 2 Celsius. Okay, and so if you observe, all my units cancel off except for joules. And so whatever answer I get here, let me calculate real quick for you. 100 times 4.184 times 2, you get 836.8 joules, and that's your final answer. In the exam, if they say give the answer in significant figures with the right significant figures, go ahead and calculate all the sig figs in these numbers. Like for example, in this case, 100 has one sig fig because these zero don't count. 4.184 has 4 sig figs, and 2 only has one sig fig. So the lowest number of sig figs you have is 1. So you would round this number up to 800 joules. If they ask you, give answer in significant figures. If they don't, you can just give the answer to like a few numbers here and there. Okay. Next question is a similar one, so you don't have trouble solving it. Just a few things that change here and there. You're still using 100 grams of water, which goes from this temperature to this temperature. And then how much, oops, another typo. How much heat did I provide to the water? But this time I'm asking you to give me in calories, small calories. And to do that, you'll have to change one thing, change the specific heat. Use the specific heat in a different units. Okay, so go ahead and solve this question on your own. And when you're done solving it, come back to the video and we'll solve it together. So if you guys have solved the question, I'm gonna try solving it on my own now. Q equals MCS delta T. Another way I remember it is Q equals MCAT, MCAT, like delta is like an A. So MCAT is a way to remember the formula. But I'm gonna plug numbers in now. M is 100 grams. CS, I told you this one, which is 100 cal per gram Celsius. And delta T is still 2 Celsius, 27 minus 5. And so Celsius cancels off. My grams cancel off. This division. What I'm left with is calories. 100 times 2 times 1, which is 200 small c calories. Okay, that's how you solve this question. And so if you realize that in this question, the mass is the same, the temperature change is the same, but you get different answers because using different units. Joules is a smaller unit, calories is a bigger unit, because 1 calorie means about 4 joules, right? So depending on the unit, your answer will be different. So make sure you use the right units. Okay, next question is the same formula, but now you need to do some equation manipulation to get in the right form. In this case, I'm telling you that I'm providing the heat with this amount of heat. I'm providing the water with this amount of heat, I'm sorry. And the mass of the water is 1 grams. The question is, what temperature change will I observe? So I'm asking you to find delta T. So go ahead and pause this video. Think over it. I'll also give you a hint that use the appropriate number for CS. from the last two questions, either 41184 or 1 calories, and then report the answer to me, or like come back and see how I do it. Okay, I'm going to try solving it on my own now. So I have Q equals MCAT, MCS delta T. Oops, my bad. MCS delta T. And I'm telling you Q, I am telling you M. You can find CS. Delta T is what I don't know. So I'm going to rearrange this equation to find delta T. And so I'm going to divide both sides. I'm going to erase this real quick. I'm going to divide both sides by MCS so that it cancels off from here. And then what I get is delta T equals Q over MCS. Okay, so it's the right form now. All I have to do is plug in numbers. I've given you Q equals 8.368 joules, mass equals 1 grams, and CS. Okay, what CS would you use here? You have joules and grams. If you use 1 gram Celsius, you don't have the right units. But if you use 4.184 joules gram Celsius, you have the right unit for joules, which cancel off. So I'm going to plug in 4.184 joules per gram Celsius. And so these joules cancel off, these grams cancel off, and the answer is 2 watt. The units for this one, the only thing left is Celsius, and this Celsius is in a denominator of another denominator. So the denominator in the denominator goes all the way on top to the numerator and becomes 2 Celsius. Okay? If you observe, this number is exactly 2 times 4.184. So if you remember the definition of CS, specific heat stands for the amount of energy required to raise temperature of 1 gram of water by 1 Celsius. But I'm providing twice the amount of heat, so I get a 2 degrees Celsius raise. Okay. Another question here is, this is a hypothetical question. I made it up for the sake of the review, but the question is, find the specific heat, find the CS of any material X that takes 100 joules, that's my Q, to heat up 500 grams of material X from this delta T. Okay, so go ahead and pause this video and then come back to it when you solve the question on your own to see how I solve it. I'm going to go ahead and solve this question now. Q stands for Q equals MCAT, and I want the equation in form of CS equals something. So I'm going to divide both sides by M delta T. So they cancel off from this side, and what I'm left with is Q M delta T. Okay, Q is given to you as 100 joules, M is given to you as 50 grams, and delta T is given to you 26 minus 25, which is 1. Okay, and so the answer here is 1 Celsius. Answer here is 2 joules per gram Celsius. And so specific heat is literally, the definition is how much energy it takes you to go from 1 gram of mass increase. How much heat it takes you to increase the temperature of 1 gram of mass by 1 Celsius. Here I'm increasing temperature of 50 grams of mass, so I need 2 for 1 Celsius, and so that's your answer. Okay. Another question is, what specific heat of a material X if it takes 200 grams, 200 joules of heat to heat up 50 grams of material from this temperature to this temperature. So go ahead and solve this on your own, and then come back to it when you're done. Okay, I'm going to solve it on my own now. This would use the same equation as this one, where CS equals Q over M delta T. And so my answer would be 200 joules over 50 grams times, in this case I have 27 minus 25, which is 2 Celsius. And if you solve this, you again get the answer as 2 joules per gram Celsius. You get the same answer because the same material. Materials have, CS is a property of the material. It does not change no matter how much material you take. It only changes if you change the material. So since both questions had material X in like in consideration, the CS remains the same as the previous one. Uh, you have more heat required to heat up because your temperature went from the temperature change went from 1 Celsius to Celsius. Okay, so if you increase temperature more, you need more heat. Okay, that's all I had for module 2. I'm going to start with module 1. But I tried to cover everything which Professor Peters went over in the slides. And so if you have any more questions, which something I didn't cover about, go ahead and ask me on my email and answer it through the email. But I'm going to do module 3 now. Module 3 starts off with conservation of mass, which basically means the mass of the reactant you take, and no matter what you do on it, the mass of the product should actually weigh the same as the reactants. Okay, you cannot just destroy something or create something and have change in the mass. That does not happen. The mass stays the same. So to explain the example, explain the equation. Let's solve this example real quick. It says you start off with 50 grams of water and you decompose it. You break it down to 30 grams of hydrogen, and the question is how much oxygen would you expect from this reaction. So go ahead and pause this video, read the question again, think over it, and then come back when you've solved it to see how I solve it. Okay, I'm going to start solving it now. So I start with 50 grams of water, and you would think that the weight of my hydrogen plus weight of my oxygen should completely add up to 50 grams, right? Nothing else is added to it. And if I say that when I broke it down, I got 30 grams of hydrogen. So the only way to find this is if I do 50 grams of water minus 30 grams of hydrogen, which gives me 20 grams of oxygen. So if I end up breaking 50 grams of water, I should expect 30 grams of hydrogen and 20 grams of oxygen. Okay, in reality, these numbers I just made up for the question, so don't quote me on these. These are all made up numbers, only for the sake of the question, so you understand the idea with simple numbers. These numbers are not real, okay? But the idea is, remember the idea, not the numbers. And so a follow-up question with that question is, in the previous example, what is the percent by mass of hydrogen and oxygen? So to do that, oh, you know what? Go ahead and solve it on your own first. So think over it, solve it, write it down, and then come back once you're done solving to see how I do it. Okay, I'm going to start solving the question now. The question is find percent by mass of hydrogen. So to find percent by mass of hydrogen, I'll do how much hydrogen I have, 30 grams, or how much weight there's through the water, 50 grams, and I multiply it by 100, and that gives me 60%. That's it. That's all it is. Okay. And to find percent mass of oxygen, there are two ways to do it. One way to do it is I could do 20 over 100. I'm sorry, 20 over 50 times 100, or I could say because water is only made of hydrogen and oxygen, so if 60% is hydrogen, the remaining 40% must be oxygen, and I did that by 100 minus 60, and this 60 comes from here. Okay, so that's what I have for conservation of mass. Now the next questions is kind of mostly typing because I want to type them out. Can you name 3 parts of an atom? So the answer would be, you can pause the video anytime you want. I'm gonna keep going with this one, but I recommend you pausing the video after every question and then answering on your own and then come back to what I say. So the answer here is protons, protons, electrons, and neutrons. What of the three contain charge on them and what kind? So the charged particles are protons and they contain a positive charge, and the electrons contain a negative charge. Okay, neutrons have no charge in the neutral. Which of the three possess significant amount of mass on them? And the answer for that one is protons and neutrons have a significant amount of mass on them. I could ask a follow-up question for this. How much is the mass on each? And the answer to that would be 1 atomic unit, or 1 atomic mass units, 1 AMU on each. Okay. The people have found the weight of protons and neutrons in terms of kilograms as well. You don't have to know that, just know its unit mass for each. Okay. Moving on, where can you find each particle in the atom? And so I'm going to find the answers people said in the review, so I can reflect those two. Okay, so people said that electrons are found in shells around the nucleus, okay, while protons and neutrons are found in the nucleus, which is in the center of the atom. Okay. The concept of shells comes up in module 4. I just mentioned it for the sake of being, just to answer this question in this one. Oops, I think I missed the center. Okay. How do you calculate the atomic number? And so to calculate the atomic number, you can say the atomic number is equal to the number of protons. Okay. I could also ask you that if in a neutral atom, protons and electrons have the same number, why can't we say atomic number equals the number of electrons? That's because atoms tend to give or take electrons and form ions. And because the number of electrons is never constant, you cannot say atomic number is equal to number of electrons, because you want atomic number to be a constant number, like a property of the element. Number of protons never change. If you change the number of protons, you actually change the species of the element. So that's always constant. So atomic number is equal to number of protons, not electrons. How do you calculate the atomic mass? To calculate atomic mass, you do number of protons plus number of neutrons. Okay, because we said protons and neutrons contain significant amount of mass on them. That's the only way to find the atomic mass of an atom. Okay, and the units would be atomic mass units as well. What letter or symbol is used to represent atomic number? The answer for this is Z. Atomic number is represented by the letter Z. What letter or symbol is used to represent atomic mass? And the answer to this question is atomic mass is represented by the letter A. Okay, in this example, 14.6c, what is the atomic mass and atomic number? Can you tell me the number of protons, electrons, and neutrons? Go ahead and pause the video, solve it on your own, and then when you're done solving, come back to the video and see how I solved it. Okay, I'm gonna start solving the question now. So if you look at this is in the form of A, Z, X, where X is the element, so it's in this case carbon, Z is the atomic number, so atomic number is 6, A is the atomic mass number, so atomic mass is 14. And so we want to find protons, electrons, and neutrons, right? So we said atomic number is equal to number of protons. So number of protons is 6. Because carbon here has no charge on it, or charge mentioned, we can assume it's not an ion, it's an atom. And so number of protons equals to number of electrons. So we'll have number of electrons as 6 as well. Number of neutrons is kind of tricky to calculate. We said that the mass number is number of protons plus number of neutrons, right? And so to calculate neutrons, I would subtract number of protons, 14, I'm sorry, the mass number 14 from the number of protons, which is 6. So that gives me 6, 12, 13, 14, 8. Okay. Next question is, what if I have the following? So same question, can you find protons, electrons, neutrons, but in this case? So let me change the color for this one. In this case, you have Z equals 6 again, and A equals 15. Okay, so how to find protons, electrons, and neutrons? I would say Z equals number of protons. So P equals 6. Electrons is equal number of protons in an atom. No charge over here, so 6 again. Neutrons would be 15 minus number of protons. This time is one big, so I'll have 9. Okay. So my question is, what is such a pair called? Such a pair as in where atomic number is the same, but the atomic mass number is different. And so these, if you guys know what they're called, you can answer them, but I'm going to say these are called isotopes. The way I remember it is, I think of my friends, where all my friends are humans as well, but they all have different weights compared to me. So all humans are isotopes of each other. This is the way I remember it. Okay. And so one question is about isotope abundance. Um, every element, oops, I want to move this question to the next page anyway. Every element has significant amount of isotopes present in the atmosphere or like in nature. And so we try to find the average atomic mass of an element because any mixture can contain any number of isotopes. So the question is, if you have two isotopes where one of them has 18 neutrons present in this amount of abundance, and the other one has 20 neutrons present in this amount of abundance, atomic number of chlorine is 17. Can you find the average atomic mass? So this one is a longer question, so go ahead and take a few minutes, solve it on your own, think over it, solve it on your own, write it down, and then once you're done with it, come back to the video and we'll solve it together. Okay, I'm going to go ahead and solve this question for you guys. Okay, let's see the first isotope. The first one has 18 neutrons. That does not tell me the atomic mass. You want to know the atomic mass, which is sum of the protons and neutrons. Atomic number is 17, so that can be number of protons, right? This is number of neutrons. I'm going to do, and I'm going to P plus N, 17 plus 18 is 35, is the atomic mass. For second isotope, I have 20 neutrons, so I'm going to do 17 plus 20, which is 37 as my atomic mass. I'm going to do 1 and 2. Okay. So to find the average atomic mass, what you do is you take atomic mass 1 and you multiply it by its percentage abundance, but in a decimal form. Okay. I think the better way of saying it, what you do is you take its percentage abundance of 1 and you divide it by 100. Okay. For the next one, you take atomic mass number 2 and you multiply by its own abundance and divide by 100 as well. Okay. And whatever sum you get, that sum is equal to your average atomic mass. Okay. So in this case, I have atomic mass 1 of 35 multiplied by 75.77 divided by 100. So it gives me 0.7577 plus my second mass is 37 and multiply that by 24.23 divided by 100. So that gives me 0.2423. Okay, so I'm supposed to be run this number through a calculator. Let me see what the answer comes out to be. 35 times 0.7577 plus 37 times 0.2423. And so the answer I get is 35.4846. Okay, and you can leave the answer in this state. But if they say to have significant figures, go ahead and calculate significant figures and put them in the answer. Okay, so that's how you find percent abundances of isotopes. A question I got in the review was, what did they give us the percent abundance and ask him to find either the mass or the percentage of that mass. And that's pretty easy to do as well. So if they give you one is green, if they give you this information, they'll have to give you, if they want to find the other mass, they have to give you at least these two. Okay, if you have one percentage and you know it's two isotopes, you can do 100 minus this percentage to find the other percentage. So you end up finding this percentage anyway, and you can find the second mass. Okay, so if that question, that do not get scared, just find this number by doing 100 minus percent 1, and then you can rearrange the equation to get a2 equals something, and then find the answer from there. Okay, moving on to the periodic table. This is also going to be a bunch of answers, me writing down the answers. So pause the video after every question and answer it real quick, and then come back to the video. So the first question is, in the periodic table, we arrange the atoms in a certain way. How do we arrange the atoms? So the thing I'm looking for here is, we arrange the atoms in the increasing order, or the increasing order of the atomic numbers. Before the table was finalized, like in really olden times, scientists would arrange them in increasing mass orders, but they found out that doing that is not the best way because the properties didn't really line up very well. So in the most recent one, we lined them up in the increasing order of atomic masses. I'm sorry, in the increasing order of atomic numbers, not masses. Okay. Next one is, the periodic table is very big, but it can be broken down. What is the collection of atoms in a vertical, that is top to bottom or up down line, called? So if I have to call this collection of atoms by a certain name, what would that name be? So think over it. The answer for this is, it will be called a group. Okay, the vertical lines are called groups. What is the collection of atoms in a horizontal line called? I should say this is a group, not groups. And then I'm going to highlight this so you know this is the answer. Next question is, what is the horizontal, left to right line in a periodic table called? And that is called a period. Okay, so lithium, sodium, potassium, rubidium, all these guys are in one group. Beryllium, magnesium, calcium are all in one group. On the other hand, boron, carbon, nitrogen, oxygen are all in a period. Okay, lithium, beryllium, carbon, boron, all of these, right from number 3 to number 10, they're all in one period, and that's period number 2. Okay. Next question is, what are the yellow elements? I'm sorry. What are the yellow elements called? So in this periodic table, all the elements highlighted in the color yellow, what are they called? And can you tell me the properties of them? So the ones on the left side, which are grouped together, are called as metals. And the properties include being malleable. Malleable means it can be hammered down into a sheet. They are ductile, which means that they can be drawn into thin wires. Yeah. Let's see what else people said in the review. They said they are good conductors. Oops, I'm sorry. Good conductors of heat and electricity. They're also shiny. And another thing they said is they have high melting and boiling points. And because they have high melting and boiling points at room temperature, which we live at, room temperature, because they haven't melted or boiled off yet, they are still solids. Okay, I don't know why Word does this with me. Why it keeps moving around so much. Okay, so metals are malleable, ductile, good conductors of heat and electricity, shiny, they have high melting and boiling points. That means they're still solid at room temperature. And so in the same picture, the question is, what are the green elements? The elements highlighted in green color. So think about it. Those are called non-metals. And because they're not metals, the properties would be exactly opposite of metals. So people said that they are brittle, so they break easily. You cannot like hammer them into like thin sheets of wire, it's straight up breakaway. They are non-conductors of heat or electricity. Electricity. That means they're insulators. That's another word for that. They have low melting points and boiling points. So since they have already melted or boiled away at room temperature, comma here, at room temperature, they are either gases or liquids. Okay. I want to point out to one point. Even though we say most of them are gases or liquids, there are some exceptions to it, like carbon in its natural form is a solid. Okay. Same applies to metals. Most metals we see are solids, except for one metal. Can you think which metal in room temperature is not a solid? The answer to that question is mercury. Mercury is a metal. You've used it in thermometers. It's not solid at room temperature. And mercury is right over here. Number 80, Hg is mercury. Okay. And then the next question is, in the same picture, what are the purple elements called? So the purple elements is this little step ladder over here, and those are called as metalloids. And metalloids, because they're between metals and non-metals, they share properties with both metals and non-metals. Okay, so the little of both, and that's a good answer for it. Awesome. Yep, that's all I have for periodic tables. If you have any question, again, you feel free to ask me and refer to your notes again. But I'm going to keep moving on with ions. Okay, ions are formed when atoms tend to gain or lose electrons. And so the first question is about that. Sometimes atoms will gain or lose electrons. What happens to their charge when they gain or lose electrons? So think about it and let me know. Okay, so when they gain electrons, because electrons are negatively charged, the atom becomes more negatively charged. Negative atom gains negative charge. Okay. If they lose electrons, they're losing negativity. At the same time, when you lose electrons, the number of protons didn't change. So the charge don't cancel off. And because now there is net more protons in the atom, when electrons are lost, atoms gain a positive charge. Okay. And then the question is, what are positive ions called and what are negative ions called? And the way to remember this is, you can say positive as in positive, and so they're called as cations. And then anions don't really have a name, they're pretty boring. Anions are negatively charged. So many typos. Negative. Okay. Next question. An ion has a +2 charge. An ion has a +2 charge, and the atomic number of the ion is 13. Calculate the number of electrons in the ion. Also, how many protons are there? Okay, so go ahead, pause the video at this point, reread the question, think about it on your own. I'm asking you for number of electrons and protons. And then once you're done solving it, come back and see how I solved it and see if your answer is right. Okay, so I want to start solving the question now. I said the atomic number is 13, so Z is 13. No matter if it's an ion or an atom, atomic numbers never change. So 13 still remains constant. And so this is number of protons. So you found number of protons to be 13, answering this question already. Okay. Then it has a +2 charge. You get a positive charge when you lose electrons. Okay. Excuse me. So number of electrons in an atom. I'm sorry for the bad handwriting. My mouse is not working now. Number of electrons in an atom is usually number of protons, right? Which is 13. But in the ion, it gains or loses electrons and is a plus charge. So it has gained Wait, it's a plus charge. I'm sorry. It has lost electrons. So I'll subtract 2 electrons from here. And what I'm left with is 11 electrons in the ion. Okay? Calculate. Okay, we found everything I asked for. Perfect. And then for the next question is, for the above ion, or the same ion, if the mass number is 27, so that's A, calculate the number of neutrons. So A is number of protons plus number of neutrons, right? A is 27. We said number of protons is 13 from the question here. And so number of neutrons would be 27. Oops, I should say neutrons would be 27 minus 13, which is equal to 14 neutrons. Okay, perfect. I'm going to move on to the next question. For another different atom, atomic number is 17. Atomic number is 17, and the mass number is 36. The charge on its ion is -1. Can you calculate protons, electrons, neutrons? Okay. So if you remember, this is the chlorine atom we found abundance for. I rounded up the mass to 36. But for the sake of the question, let's solve this part of it. We said Z. Okay, you know what? Pause the video. Pause the video. Go ahead and solve it on your own. And when I'm done solving it, come back and see how I solved it. Okay. I'm gonna start solving the question now on my own to see, and then you cross-check how you did it. We said Z, your atomic number, which is 17, and atomic mass number, which is protons plus neutrons, is 36. Okay, and we asked P, E, and N. We can say Z equal number of protons, so 17 right away. Electrons are complicated here because in an atom it would be equal to number of protons, but we have an ion whose charge is -1. So if it 17, the atom, -1 means it gained an electron. So I'm going to add a new electron here, which means 18. Okay, and neutron would be similar before 36 minus 17, which is 9. Is it 9? I think it's 19. Yeah, it's 19. Okay, I'm gonna cross check that real quick. I don't trust myself. 36 minus 17. Okay, it is 19. Never trust math that in your head. It's a quick way of doing it, but it's usually wrong, at least for me. Okay, that's how you find protons, electrons, neutrons in an ion. Okay, that was the last question. Awesome. So that's all I have for this review. I have not seen the exam, so I do not know what the exam is going to look like. But I can tell you one thing: if you go through everything you have in the materials thoroughly, you'll probably have a good exam. Okay. I really hope this exam review helped you a lot. I'm going to drop my email ID. My email ID, so you can ask me questions if you have any, is dakghone@istate.edu. Feel free to email me any questions you have. I'll try to answer it as soon as I can whenever I see the email. Oh, damn it, I hate Word. But a few pointers here and there. Your exam, exam 1 is on Wednesday. Don't forget about it. From 7 p.m. to, let me pull it up real quick so I don't use the wrong numbers. It is 7 p.m. to 8:30 p.m. And when I say 8:30 p.m., it means that at 8:30, no matter how far in the exam, is going to shut down and you won't be able to complete it. Okay. So if you want to use full 15 minutes available to you, don't start later than what does it say? I think 7:40. I would say 7:30, just so you have those 10 minutes as a really good time if you have internet problems. And if you have accommodations, it gives you more time to solve the exam. Do not start later by 7:15. But if I was you, Honestly, I would just start at 7 o'clock because internet is going to be really bad on campus because everyone's using it. So you might have connectivity trouble. And so do not risk your exam on that gamble. Um, yeah, otherwise, that's all I had for you guys. I really hope you have a good exam. All the very best for exams. And yeah, I'll see you on Thursday. Next session will be on Thursday at 5 p.m. I should say 5:10 p.m. in my regular personal room link for Zoom, and we'll go over module 4. But all before exam, and I'll see you later on.